Hello everyone, good morning. How are you all? Good morning. How are you? So today our topic is hydrogen and S block elements. Okay. I am very good. How are you? Okay. So my screen is visible and I am audible also. Okay. So on this screen, you can see I have summarized some pictures, right, in the title. Here is a sodium, lithium battery. You can see, right? Can you see the battery on the screen? There is a magnesium, there is a hydrogen, potassium, H2O2, water molecule is there in which hydrogen bonding I have shown, as well as there are what? Flame test. With the help of flame test, we can determine the S block elements. Okay. Okay, so many students have joined. Now let's start with our session. Okay, so when we talk about hydrogen, there are certain isotopes of hydrogen. You know what are the isotopes of hydrogen, right? What are the isotopes of hydrogen? Protium, deuterium, and tritium, right? These are very important isotopes of hydrogen. Next, the properties of hydrogen resembles alkali metals which lose one electron to form unipositive ions, as well as resembles halogens. Okay, their properties resembles halogen as it can gain one electron to form uninegative ion. These hydrogen or the hydrogen forms different kinds of oxides, halides, and sulfides. It has very high ionization enthalpy. We are talking about the properties now. Okay. Hydrogen does not possess metallic character under normal condition. Hydrogen forms diatomic molecules. So these are certain properties I have summarized here about the hydrogen. The next thing that is very, very important is what? Hydrides. So there are different kinds of hydrides of hydrogen. Here you can see 1, 2, and 3. So ionic hydride, which is also known as saline or salt-like. Next, covalent hydride or molecular hydride. Next, metallic, non-stoichiometric or interstitial halides. Sorry, not halide, hydrides, right? So these are the 3 hydrides of hydrogen. Okay, very, very important, right? Next. So when we talk about hydrogen, you know our day-to-day life compound, okay, water. So water contains hydrogen. The structure of water is like this way, H2O. The bond angle you can see it is what? 104.5 degree and the bond length is 95.7 picometer. So most of the human body contains water, and plant, how much amount of water is present in the plants? 95%. The physical properties of water, you know, it is colorless and tasteless. If you see water is a different color, then that is not good. Okay, that is not water. Water is always colorless and tasteless. Okay. Next, the presence of extensive hydrogen bonding is observed in the water. High freezing point, high boiling point, high heat of vaporization, and high heat of fusion is observed for water. You can see here the structure of water, vacant spaces I have shown. Okay, and hydrogen, and here hydrogen bonding is also present. Hydrogen bonding is also present. Next, when we talk about the chemical properties of hydrogen, first reaction is with the ammonia. Second reaction is with the sodium, and third reaction is what? With CO2, and next is with phosphorus. Okay, in order to form the phosphorus oxide, in order to form the phosphoric acid. So these are certain chemical properties of water molecule. The differences are what? Hard water does not give leather with the soap, whereas soft water gives leather easily. So you know that in some region or in some area of our city or in any kind of city, what happens is that at one part you will observe that the water gives maximum leather. Okay, and at different times or different places, water doesn't give any kind of leather with the soap or anything. So why that is happening? Due to the presence of hardness. Due to the presence of hardness in the water, it doesn't combines with the soap or anything, and it doesn't form the leathers. Okay, so hard water does not give a leather with the soap because of the hard water, and soft water gives the leather very, very easily. So there are two types of hardness. One is a temporary hardness and another one is a permanent hardness. So when the temporary hardness is present, temporary means what? Which we can remove. So temporary hardness is removed by just boiling. Okay, Clark method. These are the two ways with the help of which we can remove the temporary hardness. Okay, but what is actually this hardness? Okay, hardness is what? Hardness is what? The presence of Hardness is what? The presence of magnesium and calcium hydrogen carbonates in a water, which is what? Temporary hardness. Okay, which is what? Temporary hardness, and which we can remove by boiling and Clark method. Next is what? Permanent hardness, which we can remove by treatment with washing soda, Kalgan's method, ion exchange method, synthetic resin methods. And what is permanent hardness? It is due to the presence of soluble salts of magnesium and calcium in the form of their chlorides and sulfate. Very, very important. What is temporary hardness, and due to presence of which components it is known as a temporary hardness, and what is permanent hardness, and with the due to presence of which components it is known as a permanent hardness. Okay, and how you can remove it and how you can remove this. This is very, very important slide, right? Next, hydrogen peroxide. You know that very important compound of hydrogen other than water is what? Hydrogen peroxide. Its preparation, you can prepare it by using three methods. Okay, you can prepare it by using three methods. There are physical properties to that. That is what? It is colorless, miscible with water. It is non-planar. Okay, this is very, very important thing. Its structure is what? Non-planar. You can see the chemical properties of it. It decomposes on exposure. If you buy the hydrogen peroxide bottle, or you have hydrogen peroxide in your laboratory na, and if you keep that bottle cap open, okay, then you will find out that as the time will pass on, the hydrogen peroxide, due to the exposure of sunlight or surrounding, it decomposes. Okay, it decomposes into H2 and O2. Right? The uses are very, very important. Hydrogen peroxide is used as a hair bleach and disinfectant. Okay, the manufacture chemicals used in detergent manufacturing ke liye hydrogen peroxide is also used. It is used in the industries of bleaching agent, as well as in environmental chemistry. Hydrogen peroxide is mostly used. Next, very, very important compound is what? Dihydrogen. Okay, hydrogen ka very, very important compound is what? Dihydrogen. So what is the dihydrogen? So you can see dihydrogen you can prepare by different methods. Okay, and commercial method is by using water. By electrolysis of water, you can prepare dihydrogen as well as oxygen. Okay, by electrolyzing warm aqueous barium hydroxide solution between nickel electrodes. Okay, so this is what? Again, preparation of water. This is very, very important. This is known as water gas. What is the meaning of water gas? When carbon monoxide and hydrogen are present, is called the water gas. Pool gasification and water gas shift reaction also gives us water. Sorry, also gives us dihydrogen, not water. What are the physical properties? It is colorless, odorless, tasteless, and combustible. It is lighter than air and insoluble in water. You know dihydrogen. It is lighter than air and insoluble in water. You must have seen the balloons. Okay, you must have seen the balloon, hydrogen balloons. So what is present there? Dihydrogen is present, and that's why it is lighter than air. It can means वो हवा में उड़ता है जैसे ऊपर जाता है. ठीक है? Then you can see here chemical properties I have summarized. Okay, a reaction with halogen, reaction with oxygen, reaction with nitrogen, reaction with metals. Palladium is given here. Again, here reduction takes place. See, alkene का reduction हो रहा है और यहाँ पे aldehyde form हो रहा है due to the presence of CO. Okay, so there are certain very, very important chemical properties of this dihydrogen. Okay, next, uses. It is used in the synthesis of ammonia. Yeah, very, very important reaction, Haber's process. Okay, in manufacture of vanaspati fat. This is again very, very important. Manufacture of bulk organic chemicals. It is used for the manufacture of metal hydrides, preparation of HCl, metallurgical processes, Rocket fuel, yeah, it is used as a rocket fuel. Okay, whenever rockets are going into the space, now their dihydrogen fuels is used, as well as very important fuel cells. Okay, so these are good important applications of dihydrogen molecule, right? Next, now let's solve certain problems which are asked in the previous exam. Okay, so first problem, match the following and identify the correct option. COH2, temporary hardness of water, B2H6 and H2O2. Very simple. Now we have just discussed everything. Can you tell me the answer? A, B, C, D. Here is the ABCD. Okay, A, B, C, D. Which will be the correct answer? See, recent 2020 NEET exam में ये question आया हुआ है. Yeah, COH2, what is that? It is what? Water gas, or it is also known as synthesis gas. So A will have 3. Okay, next, temporary hardness of water is due to presence of what? Magnesium and calcium hydrogen carbonates. So for second, it will be first. This is magnesium and calcium hydrogen carbonate. B2H6 is what? An electron deficient hydride, right? B2H6 is what? Electron deficient hydride. And H2O2 is having non-planar structure. D is what? 4. So what is the correct option here among these A, B, C, D? You can see that A option is what? Correct. Option A is what? Correct. Any doubt in this? Yes? Should I move forward? Okay, next problem. The method used to remove temporary hardness of water is. Right now we have talked about this synthetic resin method, Kalgan's method, Clark's method, and ion exchange method. So this is very easy. Huh? What is the answer? Tell me. Yes? Yes. Any doubts or anything? Any answers? Temporary hardness. How can we remove the temporary hardness? See here, we have written temporary hardness can be removed by boiling or Clark's method. Right? So what will be the answer here? Yes, A, B, C, D. Yeah, so here answer will be C, Clark's method. Right? Next. Clark's process is used to remove the temporary hardness of water. In this method, what is the description of this method? You can see in this method, quicklime is added. Okay, and the bicarbonate present in temporary hard water react with lime water to form insoluble calcium and magnesium carbonates, which can be easily filtered out. Okay, so quicklime is added, okay, into the water, and there is a formation of lime water, and that lime water then reacts with those bicarbonates, okay, hydrogen carbonates, and you get what? Pure water, and these are the insoluble impurities present. Okay, next, the number of hydrogen bonded water molecules associated with CuSO4 5H2O is, yes, this is very important question. Yeah, can you tell me the answer? 3125. Yes, number of hydrogen bonded water molecules associated with this compound is, your answer is what? Yes, so see here, the ionic formation of CuSO4 5H2O is this type, okay, in which 4 H2O molecules are coordinate to the central Cu2 plus ion, while the 5th H2O molecules is hydrogen bonded to sulfate group. Okay, so number of hydrogen bonded water molecule associated with this is how much? 2, right? Any doubts in this? Yes. Next, which of the following statements about hydrogen is incorrect? Which is incorrect statement that we have to find out here? Okay, hydronium ion H3O plus exists freely in solution. Dihydrogen does not act as a reducing agent. Hydrogen has 3 isotopes, of which tritium is the most common, and hydrogen never acts as a cation in ionic salt. Yes, hydronium ion exists freely in solution. Dihydrogen does not act as a reducing agent. Hydrogen has 3 isotopes and these things. So see here, dihydrogen acts as a powerful reducing agent and reduces metal oxides such as CuO, ZnO, PbO, Fe3O4 to their respective metals. So that's why it is a good reducing agent. So this statement is Not correct, right? Next, hydrogen has 3 isotopes, of which protium is the most common and tritium is radioactive. So this is again not true. So these two statements are not true. It is a good reducing agent as well as protium, okay, is what easily most common isotope and tritium is radioactive. So here answer will be 2 option B, C. Okay, incorrect statement are these two. Any doubt in this? These two statements are true. Next, which of the following is electron deficient? So this is very, very easy. Which is electron deficient? What is the meaning of electron deficient species? Yes, electron deficient. Which is electron deficient here? Here answer will be 1. Okay, answer will be 1 here, not 2. Sorry. Okay, 1 na यहाँ पे लिखा है मैंने. While the 5th H2 molecule is hydrogen bonded to sulfate group. Okay, so यहाँ पे answer is 1, not 2. Sorry. Yeah, next. Which of the following is electron deficient species? Yeah, can you tell me the electron deficient species? You know BH3 is a Lewis acid, right? And it is what? B2H6. Okay, diborane. It is an electron deficient species. So our answer will be option A. Boron hydrides are electron deficient compounds. Very, very important, and please remember this. Next, the structure of H2O2 is, right now we have talked about this. What is the structure of H2O2? It is what? Non-planar. Very easy. Next, the volume strength of 1.5 normal H2O2 solution is. So this question can be asked in about, like we have seen in the mole concept also. Okay, and here also in hydrogen chapter such problems are also there. Okay, so this is very, very important. So in the problem, what is given to us? We have given the normality, that is 1.5. Okay, now what we have to determine is volume strength. So in order to determine the volume strength, we need to remember the equivalent weight of H2O2. So what is the equivalent weight of H2O2? It is what? 17. Okay, and strength of, why it is 17? Because 2 hydrogen and 2 oxygen are present. When you sum this now, what you will get? You will get the answer, means 2 are there. So that's why equivalent weight you will get, divide molecular weight divided by 2. So you will get equivalent weight 17. Okay, so strength of H2O2 is equal to its normality into its equivalent weight. What is the normality given? 1.5. Equivalent weight you can calculate in this way. Okay, right? Its molecular weight will be how much? 2 plus 16 into 2, 32. That is 34. Okay, right? Yes, right? So 34 will be its molecular weight. So dividing it by 2, you will get the equivalent weight, right? So, very good. Now H2O2, you know, यहाँ पे लिखा है 68. Okay, when H2O2 decompose, it will use 22.4 liter of oxygen. Okay, so since 68 grams of H2O2 produces 22.4 liter oxygen at NTP, therefore this much amount, okay, this much gram of H2O2 will produce how much? So cross multiplication has been takes place, and you can observe that if 68 gram will give me 22.4 liter of oxygen, then 25.5 gram will give me how much? So just make the cross multiplication and you will get the answer, that is 8.4 liter. So here our answer will be what? Option B, 8.4 liter. Any doubt? Are you understanding this? Okay, now let's move on to the next question. The OOH bond angle in H2O2 is. So this is very, very simple. In H2O2, what is the bond angle present? So it is 97 degrees. Okay, remember this. If you don't know, remember this. Next, water gas is produced by. So how you can produce the water gas? Water gas is produced by passing steam through a red hot coke, saturating hydrogen with moisture, mixing oxygen and hydrogen in the ratio of 1:2, heating a mixture of CO2 and CH4 in petroleum refineries. So what is water gas? Water gas, we have talked about it. Carbon monoxide and H2 is known as water gas. It is also known as a synthesis gas. Okay, and it is prepared by passing steam through a red hot coke. Okay, through a red hot coke. So steam. So here steam is what? H2O. I will write the reaction. H2O combines with the red hot coke. Okay, carbon to form CO plus H2. To form CO plus H2. So in this way, is the formation of synthesis gas or water gas. Okay. Next reaction. Sorry, next problem. Which of the following is the true structure of for H2O2? So which is the true structure for H2O2? Answer is B. This is the correct structure for H2O2. Okay, it is not linear. It is not like this way. It is not like this way. It is like this way. And sometimes it is also known as open book-like structure. Okay, it is also known as open book-like structure. Next, the reaction of H2O2 with H2S is an example of dash dash dash. So what is this? Reaction of H2O2 with H2S is an example of addition reaction, oxidation reaction, reduction reaction, acidic reaction. So here, when you see the reaction, now I will write the reaction. Okay, H2O2 plus what is there? H2S, right? H2S. So when this reaction takes place, there is a formation of H2O and sulfur. Okay, so this reaction is what you can see here. H2O2 oxidizes H2S into S. H2O2 oxidizes H2S into S. So this reaction is what? Oxidation. यहाँ पे क्या हो रहा है? Oxidation हो रहा है. Right? So these are all about hydrogen. Previous year question as well as certain different type of question I have summarized here. Now let's talk about the next chapter, that is what? S block elements. S block element. This is again very important chapter. Okay, in the S block element, you know that there are two groups, group 1 and group 2. Group 1 elements are alkali metals and group 2 elements are alkaline earth metal. So when we talk about the alkali metal, first of all, that the atomic and ionic radii, when we talk about their atomic and ionic radii, they increases as the atomic number increases from top to bottom. So you know alkali metal, what are those? See, here is the alkali metals, yes, and neighboring to that alkaline earth metal to the extreme left of our periodic table. To the extreme left of our periodic table. Lithium, sodium, potassium, rubidium, cesium, francium are our alkali metals, right? So their ionization energy decreases down the group. Hydration enthalpy decreases with increase in ionic size. Their physical properties are what? They are silvery white metals, soft and light metals. They have low melting point, low boiling point, alkali metals, and their salt imparts color to an oxidizing flame. मैंने आपको पहली स्लाइड में दिखाया था, देखो कलर different elements, different metals के different colors हमको flame test में दिखते हैं. These are the chemical properties of lithium, and the metals M means what? Different metals present. Okay, all the alkali metals react vigorously with halogen to form their respective ionic halides. Okay, here lithium is very useful, means all the alkali metals are very useful. So here I have summarized certain uses of these. So lithium is used to make useful alloys. Lithium is used in the thermonuclear reactions and making electrochemical cells. I have shown the battery photo, right, in the first slide. So lithium batteries are mostly used. Sodium is used to prepare the sodium lead alloy. Liquid sodium metal is used as a coolant in nuclear reactor. So in nuclear reactor, liquid sodium is used as a nuclear reactor coolant. Sorry. KCl is used as a fertilizer. You know, in fertilizers, potassium is present. Okay, so KCl is present in the fertilizer. Cesium is used in the devising photoelectric cells. So this is again very important. Which of the following alkali metal is used in the photoelectric cell? So cesium is the metal which is used in the photoelectric cell. Okay, very important things. So characteristics of the compounds of alkali metals. So when we talk about the oxides and hydroxides now, so you can see here lithium oxide, sodium oxide, and rubidium, potassium, and cesium oxide. So these are like this way. Their molecular formulas are like this. Okay, when these metal reacts with the air, they form these types of oxides. When we talk about halides now, alkali metal halides have high melting point, colorless crystalline solid. Their preparation, you can see reaction of oxide, hydroxide or carbonate with aqueous HX. You can prepare by this method. High negative enthalpies of formation for alkali metals. Melting point for these halides is like this way. Fluorine for fluorine compounds for fluorine halides, or you can say that metal fluorides. The melting point and boiling point will be high as compared to chlorine, as compared to bromine, as compared to iodine. These halides are soluble in water. Very important. The metal halides which are formed by the alkali metals are soluble in water. Next type of compounds which these S block elements like alkali metals show are the oxo acids. These oxo acids, alkali metals, form salts with oxo acids. They are soluble and thermally stable. Stability of carbonates and hydrocarbonates increases. Okay, the oxo acid stability of carbonates and hydrocarbonates increases. Anomalous behavior of lithium. You know that I have told you lithium, sodium, potassium, rubidium, cesium, and francium. Okay, so lithium, even though it is in the alkali metal, it shows certain anomalous behavior. Okay, why does it show the anomalous behavior? Very, very important, because it is having exceptionally small size. Okay, and as well as it is having very, very, very high polarizing power. Okay, and it is having very, very high polarizing power, and these are the two things due to which lithium shows anomalous behavior as compared to the other elements present in a group. You know that sodium and potassium are biologically important for our body. So sodium ion participates in the nuclear signal transmissions. Okay, a regulator of flow of water across our cell membranes. Potassium ions activate many enzymes present in our body and oxidation of glucose to produce ATP. So these are certain biological importance of alkali metals, that is sodium and potassium. Now, you know there are certain compounds of sodium like sodium carbonate and sodium chloride and sodium hydroxide. Okay, so I have summarized 3 compounds of sodium here. Sodium carbonate, washing soda, we called it as a washing soda, which is prepared by using Solvay process. Okay, how you can prepare it? By using a Solvay process. The properties of that is what? White crystalline solid, and it is soluble in water. You can see the reaction also, sodium carbonate reactions, right? It is used in a water softening, laundering, cleaning, manufacturing a laboratory reagent. So these are the certain uses of sodium carbonate. Next, sodium chloride. So sodium chloride is prepared by crude NaCl by crystallizing of brine solution. Okay, brine solution ka crystallization karne ke baad you get a crude NaCl. Pure NaCl is obtained by dissolving this crude salt in minimum water and filtering the removable insoluble impurities. Okay, it is known as a common salt. NaCl, you know, it is a common salt, right? If you don't know, then please remember this. Okay, next, sodium hydroxide. It is again a very, very good compound of sodium. It can be manufactured by Kastner-Kellner reaction or Kastner-Kellner sale. Okay, it is used in the manufacture of soap, paper, petroleum refining. Next compound is what? Hydrogen, sodium hydrogen carbonate. Okay, sodium hydrogen carbonate, can prepare it like this way. Okay, now let's talk about the alkaline earth metal. So alkaline earth metal, like where is alkali metal, they are neighboring to the alkali metals. Alkaline earth metal, beryllium, right? Beryllium, magnesium, calcium, barium, like that way our alkaline earth metals are present. Okay, so they have smaller atomic and ionic radius, but those increases with increasing atomic number, top to bottom, it goes on increases. So when we talk about the ionization energy first for these metals, now they have higher than corresponding group 1 metals, and IE2 is smaller than the corresponding alkali metals. Okay, hydration enthalpy, when we talk, decreases with increase in ionic size down the group. When we talk about the physical properties, you can see that they are also silvery white metals, lustrous and relatively soft, but harder than alkali metals. They are soft, but they are harder than respect to alkali metals. Alkali metals are very, very soft metals, even though they are metals. Okay, melting point, boiling point higher than the corresponding alkali metals. Electropositive character increases down the group. When we talk about the chemical properties of this alkaline earth metal, you can see that beryllium and magnesium are kinetically inert to oxygen and water. Magnesium is more electropositive and it burns in air. Calcium, strontium and barium with air forms their respective oxide and nitride. Okay, with respect to oxide and nitride. When they react with halide, they form their respective halides. Okay, reaction of barium chloride with LiLH4, you can see here BaH2 is formed. Okay, when metal reacts with hydrogen chloride, hydrogen is liberated. When metal reacts with ammonia, they form their ammoniacal solution and they impart blue color to this solution, and there are certain free electrons present here. Okay, uses of this alkaline earth metal are what? Beryllium is used in the manufacture of alloys, and metallic beryllium is used for making windows of X-ray tubes. Okay, magnesium, aluminum alloys are used in the aircraft construction. Calcium is used in the extraction of metals. Radium is used in the radiotherapy. So these are all very, very important uses of this alkaline earth metal. When we talk about the characteristics of these compounds of alkaline earth metal, you can see here there are certain oxides and hydroxides of alkaline earth metal. They form alkaline earth metal. When burned with oxygen, they form their respective oxide in this way, Me, metal and O. All oxides except BuO are basic in nature. So all oxides are basic in nature except BeO, it is not basic in nature. Okay, when we talk about the hydroxide of beryllium, it is amphoteric in nature. Very, very important. These two lines are very, very important. Okay. Halides. So except beryllium halides, all other halides are ionic. Okay. Like the lithium, beryllium, which is the first element of this alkaline earth metal, it shows anomalous behavior. Okay. It shows certain anomalous behavior, right? So tendency to form halide hydrides decreases gradually. The salts of oxoacid forms carbonates, sulfates, and nitrates. The anomalous behavior of beryllium is again due to what? See here, due to its small size and ionic size. Okay, next, does not exhibit coordination number more than 4. Its oxide and hydroxides are what? Amphoteric. They are amphoteric. They are not basic. Okay, they are amphoteric. Oxide is basic, but its oxide is what? Amphoteric. Beryllium oxide is amphoteric. Its hydroxide is again amphoteric. Okay, and you know, very, very important, it shows diagonal relationship with aluminum, which is the next group element. Okay, group third element. Biological importance of magnesium and calcium. So this is very, very important. Calcium is present in what? Teeth. I have shown in the first slide also. Teeth is also there. One small teeth is there. So all enzymes that utilizes ATP in PO4 phosphate transfer requires magnesium. Okay, as a cofactor. Again, chlorophyll contains magnesium, right? Calcium is present in the bones and the teeth of human body. Important in neuromuscular function, intraneuronal transmission, and blood coagulation. So these are very, very biological, very, very good importance of and biological importance of these two metals, magnesium and calcium. Okay, any doubt in this? You can ask. Yeah. Okay, next. Let's solve certain problems of S block element, that is alkali plus alkaline earth metal. Let's combine both the things. Okay. So ionic mobility of which of the following alkali metal ions is lowest when aqueous solution of their salts are put under an electric field? So ionic mobility of which of the following alkali metals? Potassium, lithium, rubidium, and sodium. Whose is lowest when aqueous solution of their salts are put under an electric field? So who will have the least ionic mobility here? Yes, see here, very, very important. Okay, the hydration enthalpy of alkali metal ions goes on decreases as increasing their ionic sizes. So you can see here lithium being smallest, then sodium, then potassium, rubidium, and cesium. Okay, hence lithium is having maximum degree of hydration. Here you can see lithium is having the maximum degree of hydration, will be least mobile. Since it is smaller in size, all the water molecule present around it, what they do, they hydrate that given lithium molecule. They surround the lithium molecule or lithium ion. Okay, and due to which, even though it is smaller in size, so many water molecules are surrounding to it, and that's why it becomes bulky. That's why it becomes bulky in nature. It becomes larger. Overall, their size becomes large. And since it is larger in the size, to move into the solution, it requires, means it takes more time, and that's why its speed slow down. Are you getting it? उसका साइज बड़ा हो जाता है. उसका साइज बड़ा होने के कारण उसको भागने के लिए सॉल्यूशन में ज्यादा टाइम लगता है क्योंकि वो बड़ा हो गया है साइज में, and that's why its speed becomes slower. So that's why even though lithium is smaller in size actually, but due to its high degree of hydration, its size becomes bigger, and due to bigger size, its mobility decreases. So when we talk about the order of ionic mobility in the solution, rubidium will be higher and lithium will be least. So your answer will be what? Lithium. That is option C. Any doubt in this? Yeah, let's move on to the next question. Which one of the alkali metal forms only the normal oxide M2O on heating in air? Yes. Which will form M2O on heating in air? Yeah. So let's talk about this. So when alkali metals are heated in atmosphere of oxygen, they ignite and they form their respective oxides. But on combustion of lithium, it forms Li2O. I have told you, lithium forms Li2O, sodium forms Na2O2, right? We have talked about this. And further forms MO2, that is potassium, rubidium, and cesium. They form this type of oxide. So here M2O type of oxide, who is going to form? Lithium is going to form. So our answer will be what? C. Any doubt in this? Next, the ease of adsorption of the hydrated alkali metal ion on an ion exchange resin follows the order. Ease of adsorption follows the order. Yes, A, B, C, D. Yes, any answers? Yeah. Okay, so let's talk about here. The order of decreasing hydration enthalpy of the alkali metals is what? Like this way. Right? Rubidium is least hydrated as compared to lithium. So the ease of adsorption of hydrated ions will be what? Reverse. So that's why here answer will be what? Rubidium over potassium over sodium over lithium. So this will be the correct order because hydrated, those which are more hydrated, they will easily adsorb, okay, in the ion exchange resin. Next, which of the alkali metal chloride forms its dihydrate salt MCl.H2O easily? Yes, LiCl, rubidium Cl, cesium Cl, and KCl. Yeah, tell me which will form? Yes, easily. Here answer is A. LiCl is deliquescent and it crystallizes to form aqueous solution as hydrates in this type. So our answer is what? A. Any doubt in this? See, frequently asked question I have summarized here. Okay. Next problem. Crude sodium chloride obtained by crystallization of brine solution should not contain MgSO4, MgCl2, Na2SO4, and CaSO4. Yeah, what will be the answer here? Crude sodium chloride obtained by crystallization of brine solution does not contain. We need to find out which does not contain. Okay, so here our answer will be A. Crude sodium chloride generally obtained by crystallization of brine solution contains sodium sulfate, calcium sulfate, calcium chloride, and magnesium chloride as its impurities. Okay, crude sodium chloride does not contain MgSO4. So that's why our option A will be the correct answer. Next problem. In Castor Kellner cell for production of sodium hydroxide, what is happening? Brine is electrolyzed using graphite electrodes. Molten sodium chloride is electrolyzed. Sodium amalgam is formed at mercury cathode. Brine is electrolyzed with platinum electrodes. So what is happening with Castor Kellner cell? Yeah. So in Castor Kellner cell, remember this, sodium amalgam is formed at mercury cathode. Sodium amalgam is formed at the mercury cathode. A brine solution is electrolyte using a mercury cathode, and mercury is used as a cathode and carbon is used as a anode in Castor Kellner cell. Okay? Any doubt in this? You have to remember these things. Okay? Then only it will be easy for you. Next, the following metal ion activates many enzymes, participates in the oxidation of glucose to produce ATP with the sodium, is responsible for transmission of nerve signal. We have talked about this in the uses. Tell me, what is the answer? Iron, calcium, copper, and potassium. Yes? Iron, copper, calcium, and potassium. What is the answer? Yes? Used in the transmission of nerve signal. So here potassium, iron are the most abundant cations within our cell fluids, where they activate many enzymes to participate into the oxidation of glucose to produce ATPs in our body. With sodium, they are responsible for the transmission of nerve signal. So potassium is very, very important to our body, to our human body. Okay, next problem. The function of sodium pump is biological process operating in each and every cell of all animals. Which of the following biologically important ions is also constituent of this pump? Yeah, so which is present here? Magnesium. This is magnesium. Yeah, sodium pump function, biological process. What is present? Sodium pump. Okay, so potassium is present here. Okay, so potassium is present here with the sodium pump. Okay, biological process operating in each and every cell of all animals. Which of the following biologically important ions are constituent of this pump? So which of the ion? So here K plus is the answer. Right now we have talked. Converse question is present here. HCl was passed through a solution of CaCl2, MgCl2 and NaCl. Which of the following compound crystallizes? Yes, CaCl2, MgCl2 and NaCl. What is the answer here? So your answer is what? Only NaCl. B answer. So CaCl2 and MgCl2 are soluble, more soluble than NaCl. Thus, when HCl is passed through a solution containing CaCl2, MgCl2 and NaCl, only NaCl got crystallized. So which of the following is going to crystallize? Only NaCl is going to crystallize. Any doubt in this? Yeah, next problem. Which of the following is an amphoteric oxide? Yeah, not oxide, hydroxide. Very easy. We have discussed about this in this session. What will be the answer here? Amphoteric hydroxide, A, B, C, D. Yeah. Okay, A answer is there. Okay, beryllium has amphoteric oxide as well as amphoteric hydroxide. So it is amphoteric in nature as it reacts with acid as well as alkali both. What is amphoteric? Which can react with acid as well as alkali is known as what? Amphoteric. So it reacts with base like this way and acid like this way. Okay. Next, among these hydrides, the order of ionic character is. Okay. Among these hydrides, the ionic character ka order kya hoga? A, B, C, D. Yeah. Can you tell me the order? A, B, C, D. Yes. Can you tell me the order? A, B, C, D. No? Okay. So here the order is what? A. Beryllium over calcium over barium. Okay. So on moving down the group, metallic character of the metals increases. And that's why ionic character of metal hydride also go on increases. So BeH2 will be least ionic. This will be the correct order. Very important question. Yes. Any doubt in this? Yes. Okay. Next problem. On heating, which of the following releases CO2 most easily? So which is going to remove or release CO2 very easily? Sodium carbonate, magnesium carbonate, calcium carbonate and potassium carbonate. Yeah. Releases CO2 very easily. What do you think? What will be the answer? All are the carbonates. Which will easily remove the CO2? So here, stability of carbonate increases down the group with increase in the size of the metal ion. Okay. Also, the alkali metal carbonates are more soluble than the alkaline earth metal carbonates. Okay. So hence, MgCO3 is least stable and it releases CO2 most easily. So that's why here our answer is what? This. Okay. This is our answer. That is option B is correct answer here. Why? Because it is least stable. And that's why it releases CO2 very easily on heating. Please remember this. Okay. Any doubt? Okay. Now let's move on to the next problem. Solubility of alkaline earth metal sulfates in water decreases in this sequence. So here alkaline earth metal I have considered. Tell me what will be the solubility of this alkaline earth metal sulfates in water. Yeah. Can you tell me the answer? A, B, C, D? Yes. Yes. What will be the solubility? A, B, C, D. Yes. So see here, solubility of this alkaline earth metal sulfates goes on decreases down the group because hydration energy decreases. And on which hydration energy depends? It depends upon the smaller the size of the ion, right? Smaller the size of the ion, okay, more will be the hydration energy. More will be the hydration energy. Why? Because more water molecule. Hydration energy means what? If you take a metal and you dip into the water, what will happen? When more water molecule can surround that given metal, then we can say that the hydration energy for that given metal is more. Okay, so more will be the hydration energy when size will be smaller. So as we move down from top to bottom, what is happening? The size is decreasing. Sorry, size is increasing. So as size is increasing, the hydration energy, what is happening from top to bottom? Hydration energy go on decreases. Okay, because size is increasing. At topmost, the hydration energy is maximum. Okay, it is maximum. So what is happening here? Solubility of alkaline earth metal sulfide go on decreases. Why? Because their hydration energy decreases. So first metal जो small होगा, जिसका साइज स्मॉल होगा, उसका हाइड्रेशन एनर्जी ज्यादा होगा और उस वजह से उसका जो सोल्युबिलिटी होगा वाटर में वो ज्यादा होगा. तो इसमें जब हम लोग बात कर रहे हैं अल्कलाइन अर्थ मेटल का, इसमें सबसे स्मॉल साइज किसका है? स्ट्रोंशियम, कैल्शियम, मैग्नीशियम, बेरियम. These are our metals. So which are having the smallest size here? Yes, when we talk about this alkaline earth metal, magnesium, then calcium, then strontium, and then barium. Okay, any doubt in this? Do you get the idea of hydration energy? What I'm talking about, the size of that, what I'm talking about, the solubility of that. More hydration energy, more solubility. In what? Water. More solubility in water. More solubility in water. Okay. Any doubt in this? Do you get the idea of hydration energy, right? Okay, next question. In context with beryllium, which one of the following statement is incorrect? Beryllium के बारे में है, ठीक है? और हमको क्या देखना है? Incorrect statement देखना है. It is rendered passive by nitric acid. It forms Be2C. This type of carbide is formed by beryllium. Its salts rarely hydrolyzes. Its hydride is electron deficient and polymeric. Its hydride is electron deficient and polymeric. So what is incorrect among these? So here the incorrect statement is what? Option C. Its salts rarely hydrolyzes. So let's see. Due to very small size of beryllium, beryllium salts are rarely hydrolyzed. Okay. And here what is given? It is rarely hydrolyzed. That is not the case. It can easily hydrolyze. Okay. वो easily hydrolyze हो जाता है. Rarely नहीं होता है. Easily hydrolyze हो जाता है because of its smaller size. Okay. Because of its smaller size and it is having high hydration energy because of its small size. Okay. अभी हम लोगों ने बात किया साइज के बारे में. हाइड्रेशन एनर्जी ज्यादा मतलब सोल्युबिलिटी भी क्या हो जाती है? ज्यादा हो जाती है. Right? They have more solubility. So that's why this statement is incorrect statement. And other three statements are what? Correct statement. Correct, correct, and correct. So for beryllium, it is rendered passive by nitric acid. Yes. It forms carbide like this type. Yes. Its hydrides are electron deficient. Yes. And they are polymeric. Yes. So information for beryllium very, very important. Okay. इससे अलग टाइप से भी क्वेश्चन फॉर्म हो सकता है. Okay. Next problem. Yeah, the suspension of slake lime in water is known as lime water, milk of lime, quick lime, aqueous solution of slake lime. So suspension of slake lime in water is known as milk of lime. Okay, it is known as milk of lime. Please remember this. Okay, so quick lime is what? CaO. When it reacts with water, it gives slake lime. This is the what structure of slake lime or formula for slake lime. This process is known as slaking of lime. And the paste of lime in water, that is the suspension, is called milk of lime, while the filtered and clear solution is known as lime water. Okay, lime water, what is the meaning of lime water? It is the filtered and clear solution of milk of lime. Okay, so this is the reaction here. Please remember this, consider this. Okay, any doubt? Okay, so I will move forward. Next, The product obtained as a result of reaction of nitrogen with calcium carbide. So here, actually, what is that? This 2 is present here. Okay. So what is the reaction between nitrogen and calcium carbide? Okay, nitrogen and calcium carbide. So what you will get when you will get as a result of this given reaction. So when nitrogen reacts with our calcium carbide, now there is a formation of nitroline. See, there is a formation of nitroline and carbon is as it is. Okay, carbon remove हो जाएगा, nitrogen चला जाएगा, एक carbon निकलता है, एक carbon nitrogen यहाँ पे रुकता है, वो जो product form होता है, that is known as nitroline. So what is our correct option? A, B, C, D. Yeah, Cn twice. So answer will be what? C. Okay, any doubt in this? Okay, now let's talk about the next problem. Enzyme that utilizes ATP in phosphate transfer requires an alkaline earth metal M as the cofactor, and that metal is, yeah, for ATP transformation, we have talked about this in the uses. Yes, strontium, magnesium, beryllium, and calcium, which is used for enzymes. Yes, in order to produce the ATPs. Yes, any answers? You can guess also. You can tell me in the chat box what is the correct answer. Can you tell me? A, B, C, D? Yes, 9 participants are there. And we have talked about this. Yeah, many questions are asked about this biological importance of ATP and everything. Yeah, anyone can answer this question? Yes. Strontium, beryllium, magnesium, and calcium, which is used in the enzymes, which is used as a cofactor with the enzyme, which utilizes ATP in phosphate transfer, requires an alkaline earth metal. So what is the answer for this? Yes, so your answer is what? Magnesium. Okay, your answer is what? Magnesium. I will give you the answer. Okay, no problem. So all enzymes utilizes ATP in phosphate transfer requires magnesium as cofactor. Very, very, very important. Try to remember this. Most of the time, such a type of question is reframed. Right now, we have solved this problem. Okay, so रिफ्रेमिंग हो रहा है नीट के एग्जाम में, बार बार ऐसा क्वेश्चन आ रहा है बायोलॉजिकल इंपॉर्टेंस पे, सोडियम का बायोलॉजिकल, कैल्शियम का, मैग्नीशियम का, ठीक है, पोटेशियम का बायोलॉजिकल इंपॉर्टेंस पढ़ो, ध्यान में रखो, दैट इज वेरी वेरी इंपॉर्टेंट. एक क्वेश्चन लिटरली आएगा. ओके, एनी डाउट इन दिस? ओके, नेक्स्ट प्रॉब्लम. Which of the following statement is false? Yeah. So now tell me which of the following statement is false. Calcium 2 plus ions are not important in maintaining the regular beating of the heart. Mg2 plus ions are important in the green parts of the plants. Mg2 plus ion forms a complex with ATP and Ca2 plus ions are important in blood clotting. हम लोगों को यहाँ पे ढूंढना है false statement. हम लोगों ने जब biological importance देखी, we have talked like that calcium is used in the very important in the blood clotting, and right now we have solved the problem in ATP. Okay, when phosphate transformation is takes place, Mg2 plus ions are required, which forms a complex with the ATP. Next, Mg2 plus ions are important in the green plants. Yes, in chlorophyll, Mg2 plus ions are present. So all these three statements are what? True. All these three statements are what? True. Which statement is false here? First statement is false. So this statement is false. Okay, Ca2 plus ions are not important in maintaining the regular beating of the heart. This is the what? Incorrect statement. Ca2 plus ions actually required to trigger the concentration of muscles, and it is used to maintain the regular beating of the heart. Actually, it is useful. यहाँ पे लिखा है not useful. So that is not correct. So that is the incorrect statement. Okay, that is a false statement. Actually, calcium 2 plus is required. So such type of question can be reframed different way. Okay, which is the true statement. और वहाँ पे not नहीं लिखा होगा. So calcium 2 plus is used. Okay, for the to trigger the concentration of muscles. Sorry, not concentration. It is a contraction. Okay, for the contractions of muscle and to maintain the regular beating of the heart. So this is about all about S and hydrogen. Okay, So that's it for today's session. If you have any doubts, you can talk to me right now. You can message me. Okay. How was the session? You can tell me. Was these questions helpful for you? Okay. We have talked about most of the things. We have covered all the things about hydrogen and S block elements. Some PYQs also we have solved today. Try to remember the biological importance of these four metals as well as berylliums, oxide and hydroxide. They are amphoteric in nature. Okay, H2O2 structure is non-planar. Okay, H2O2 molecule. Okay, okay. So any doubt in this? Anything? You can ask me the question. Okay. So you have any questions? Yes? Okay, no question, ma'am. Okay. Okay, chalo fir, go and study about hydrogen and S block elements and try to solve more and more problems regarding this. If you have any doubt, you can talk to me. Tomorrow, we will going to talk about the chemical kinetics chapter. Okay. So let's prepare for that also. And we will meet tomorrow on the same time. Okay. Thank you for joining in. Bye-bye. Have a nice day. Yes. Thank you. Thank you. Yes. Bye-bye.